Everyone, welcome to this video. Today we'll be going through JC2H2 Math Inequalities. So I'll go through an introduction of what inequalities is, as well as giving some content. Then I'll go through some example inequality questions across different scenarios. And then I'll go through a summary and some key learning points. And so this is some general math inequality advice I have, which is with regards to terminology, numerator and denominator, the sketching of diagrams, as well as some last-stage methods. And so for terminology, some questions may ask you to solve algebraically. And what algebraically means is that in such questions, you cannot use your graphing calculator to instantly get the answer. Nonetheless, you can still use drawings of quadratic, cubic, and even quartic curves. What this means is that you can think of the quadratic curve, which is x power 2, cubic curve, which is x power 3, and quartic curve, which is x power 4, to determine what will happen. And so this is a bit unclear, but I'll explain more in the third tip. So there's also another thing, which is no solution versus rejecting an answer. So at the end of your question, you may have multiple sets of answers available. And so you need to know when you need to have no solution and when you reject an answer. No solution means that there isn't even a numerical answer available in the first place. Like let's say there's y equal fx, and then there's no value of x from negative infinity to positive infinity that can satisfy the given question at all. But rejecting the answer means that there is at least a solution existing in the first place. But you cannot do so because, like in this case, in this example, x must be greater than 0. So if you get x minus 2, it's technically a solution, but you have to reject it because it doesn't lie with the set notations. Then, so this is the second tip, greater than or equal to. So in the question above, you see x squared minus x plus 2 over x squared plus 1 minus a times x minus a less than or equal to 0. You notice that as you look down at the solution, it's minus 1 less than x less than a. There's no equal to sign. And this is because when you solve it, you realize that the answer is actually x equal a and x equal minus 1. But the important thing to take note there is that when you look here, if you substitute a or you substitute minus 1, this entire denominator will be equal to 0. And so if it's 0, that means the entire fraction will be undefined. And in this case, the thing will not work. So that's why when you write your final answer, you cannot have the equal sign down here. And so just check your denominators to just see if the range is inclusive of the endpoints or not when you are answering your questions. Then for the third tip of sketching diagrams. In general, when we are sketching diagrams or polynomial functions, we can pay special attention to the roots as well as the tail ends of the graph. So, as I said in tip 1, you may be asked to solve algebraically, but this doesn't mean that we can simulate numbers into the equation. Like let's say in this case, as x tends to infinity, we know that y will also go to infinity. Or if we go to x equal negative infinity, then y will extend to negative infinity as well. Or as you approach 0, it becomes a root. So you can still use this logic as part of your answering technique. And even if it's not either as part of the answer, it's also a good visualization to see what the graph generally looks like. And you can do so on your graphing calculator. And then the last tip is more of those last stitch methods. So when you use your GC, you can use your GC to check the answers, even if they say solve algebraically. Because during the exam, Cambridge won't be able to know whether you're actually using your GC or not. Of course, you cannot use your GC as a shortcut, but you can just use it as an opportunity to verify your answers. And in some cases, some questions may actually require you to find the intersection points using the GC, especially if the numbers are funny, such as 3.71823, blah, 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 blah. Those kind of funny numbers is very hard to find algebraically, and in some cases, you just have to use your graphing calculator. And so, you can also try to draw a graph to represent the inequalities on paper. And what I mean can be your number lines, your cubic, quadratic lines as well. And so, these are also ways to visualize your answer. And then, in the case of substitution questions, which we'll carry on later, you can try and replace x with everything until you get a fit. And what I mean is that there will be a part 1 question, which asks you to solve with x. And then in the second question, you are meant to replace x with something else. And as long as you replace it with something like x squared 1 over x, x minus 2, it will always ensure that the whole equation still remains consistent within the inequality. And so that will be better explained when I go through the questions later. So There are several types of inequality equations available, as well as some simultaneous equation questions, which are also part of inequality. So there are some financial related questions, some algebraic questions. Then I'll go on to the inequality questions, which can be more general, can be related to modulus, as well as some inequality questions. And so the first set of questions will be financial questions. So in this case, Mr. Mock invested $50,000 into three funds, A, B, and C, for 6% and 8% and 10% respectively. So what that means is that when you invest the fund inside, you put 100% of A inside, you get 108%. Or if you put 100% to A, you get 106% back. Then if you put 100% to B, you get 108% back. And then the same for C. If you put 100% into C, you get 110% of C back. So in the end, Mr. Mock attained a total return of 3,700, and he invested twice as much money in Fund A as Fund C. And so the question is to find how much he invested in each fund. So in this question, what you are meant to do is to find three sets of equations. And so these are the kind of equations you can come up with. So first of all, we know that across these funds A, B, and C, the total of all the investment at the start will be $50,000. The second equation is that your returns on investment, your 6% of A, your 8% of B, and your 10% of C will be equal to the 3,700 that he got in return. Then the third equation is based on this statement here. He invested twice as much money in Fund A as Fund C. So that just means that A equal to C. You bring everything to one side to get a number of 0, and that's your third equation. Afterwards, you can go to your graphing calculator and insert all these equations into a matrix. And when you put it into the matrix, it will then solve on its own to get this answer, which is he invested 30,000 in A, 15,000 in B, 5,000 in C. So note that yes, there are numbers such as 50,000, 6,000, 6%, 3,700. But in some cases, such as invest twice as much money in Fund A as Fund C, you actually just have to focus on the algebra itself, not necessarily a number. And so you have to infer these kind of things and make the third equation by that way. So here's another financial question. A banker is trying to help a client to invest $100,000 in stocks. He shortlisted three stocks: high risk, moderate risk, low risk, with a projected rate of return of 12%, 8%, and 4% per annum respectively. And so to achieve a projected rate of return of 10% per annum from the $100,000, they invested such the amount invested into stock L is equal to the total sum of 20% of the amount invested in stock H and 10% of the amount invested in stock M. Assuming that all the money is invested, determine how much did the banker invest in the three stocks. So similar to the last question, we can try and create three different variables and then set it to be such that the total is equal to 100,000. So that will mean the first equation we can find is that high risk plus moderate risk plus low risk is all equal to $100,000. Then 12% of the high risk, the 8% of the moderate risk, and the 4% of the low risk will equal to 10% per annum from the 100,000. And then lastly, the last part of the sentence, invest such that the stock L is equal to total sum of 20% of the amount invested in H and 10% of the amount of stock invested in stock M. And so this is what you will get. H, which is the high risk, M is the moderate risk, L is the low risk. That will equal 100,000. Then second equation, 0.12H plus 0.08M plus 0.04L equals 10,000. Then your third equation is that 0.2H plus 0.1M equal L. Bring all of that onto the left hand side, and that's your final equation. Pump this into the GC and you will get H equals 65,000, M equal 20,000, and L equal 15,000. And so that's how you do it. It may sound very weird to get the third equation, but as long as you can try and have an understanding of what it is, and you just pump it in, you should be able to get some nice number inside. Or even if it's not a nice number, it still should logically be there or thereabout. So a quick tip for these financial questions is that if you have questions which have 4 variables or more, so in case of the previous question you have H, M, L, let's say they add a Z, then you can also use your GC to just evaluate the answer, even if it looks intimidating. Then in the case of currency conversion, there are some questions which will have questions in US dollars, Russian rubles, Singapore dollars, Australian dollars, Danish kroner, basically any kind of currency. The thing with those questions is that you have to convert everything to a common currency first. Then you can properly put it into your GC, such as converting everything to Singapore dollars. The questions will make sure to have a conversion rate so that you can put everything there, but this is a possible question that can happen. And all the variables may not necessarily be given directly, so you have to create an expression for the unknowns and use it as one equation, such as the 0.2h plus 0.1m equal L. So this is the second scenario questions, which is algebraic linear equations. So in this case, the graph of y equal x cubed plus ax squared plus bx plus c passes through the points minus 3, 1, 1 minus 5, and 2 minus 3. And so they ask you to find the values of a, b, and c. So in this case, you can just substitute the values of x and y for each of the different coordinates. So when x is minus 3 and y equal 1, you pump that into the equation. You get the left hand side of y, and you get the right hand side of x. And so you'll get that equation. The same can be said for x equal 1 and y equal minus 5. You get a plus b plus c equal minus 6. And at x equal 2, y equal 3, you'll get that equation as well. Just like the financial question, you take all these three equations, pump it into a matrix in your graphing calculator, and you should be able to get this answer. And so this is another question which has slightly more tricky parts into it. So 4 housewives go to the supermarket together and each buy 3 different types of ham: picnic ham, honey baked ham, and turkey ham. The weights of the ham and the total amount paid by each of the 4 housewives are shown in the table. And so assuming that for each type of ham, the price per kilogram paid by each housewife is the same, calculate the total outcome that Mrs. Q has paid. Now, basically this is just an extension of the previous questions. You still have to find the rate of the picnic ham, the honey baked ham, and the turkey ham. It's just that after you solve it, you pump it back into a fourth equation to get your m. And so, we first let P, H, and T be the price of a kg of picnic ham, honey baked ham, and turkey ham respectively. Then, we'll pump this into the equations below. So 1.5p plus 0.6h plus 2.25t equals 4.89. So that first equation represents Mrs. Lee. The second equation represents Mrs. Tan. And the third equation represents Mrs. Goh. The fourth equation represents Mrs. Teo. But we will not use it in the GC because we don't have a definite number of what m is. So from the GC, we pump those first 3 equations inside to get these values of P, H, and T. Then we will go find m by substituting it into the fourth equation, which then leads to a 4.87 for m. Then we will now move on to the general inequality questions. And so, given that a is a positive real number, solve this inequality. You know, this is similar to the tip I showed in the last question, or in the last tip. So when you solve it, you try and make it such that you can find one side which is definitely positive or definitely negative. So in these kind of questions, you can try and complete the square. So what I mean by complete the square is that you try and get an all square portion, which in this case is your x minus half all square plus 7 over 4. And the thing is that for that numerator, it's always going to be positive. The thing is that x minus half all square is always greater than or equal to 1. Always greater than or equal to 0. Then your 7 over 4 is always positive. And so if your numerator is always positive, in order for your right hand side to be less or than or equal to 0, that means your denominator has to be the one that's negative. Because if it's positive, the entire left hand side will be positive. So this is the only scenario you can get, which is your x minus a and x plus 1 is less than 0. So in that case, you solve for it, you draw your quadratic graph and see when it's negative, which in this case is minus 1, is less than x, which is less than a. And as I mentioned in tip 2, you have to check that your x equal minus 1 and x equal a cannot be included. So these two endpoints are not included because when you pump them back into the original equation, you'll end up getting an undefined fraction. And so that in that case will not count. So yeah, try and see the denominator or numerator and see if it's also positive or negative. Because then this eliminates the need to check both parts of the fraction, whether it's the top or the bottom. And then you can just focus on one or the other. This second question is more of a thinking and logic question rather than actual inequality, but I still think it's very interesting. So the triangle inequality states that for any triangle, the sum of the lengths of any two sides must be greater than or equal to the length of the remaining side. If the size of a plot of land or area are x plus 3, and 10 minus 2x, explain why 1 is less than x is less than 5. So for this question, there are two parts. You focus on the 1 and you focus on the 5. So the first part, which is about finding 5, you just do what the question told you, is that the sum of two sides must be greater than or equal to the length of the remaining side. So you plumb that in, and you'll get x is less than or equal to 5. But why we remove the x equal 5 is because if x equal 5, 10 minus 2x will just be 0. And so that's why we cannot x equal 5 specifically. And so in that case, it's just s is less than 5. The second step is more of a logic, because it's not possible for two sides of 4 cm to be long enough to connect the ends of an 8 meter side. And so this means that the sides have to be greater than 1. Because if we have x equal 1, then you have x plus 3 equal 1 plus 3 equal 4. In that case, it will no longer be possible. And so there isn't exactly much math in this. It's more just of a logic processing. And so these kind of questions and using this kind of logic still works. But it's just that you have to think a little bit more out of the box. And so this is one of the more interesting questions that I came across. Then now we have modulus questions. So for a modulus of x, basically that means when x is positive, x will be greater than 0. And when the expression is minus x, x is less than 0. So when y equals fx, and when the expression is fx, fx is greater than 0. But when the expression is negative fx, then fx is less than 0. So when you try to sketch the graph of y equal the whole modulus of fx, we retain the portion of the graph where y equal fx is above or on the x-axis, and then we reflect it about the x-axis and take the remaining portion of the graph of y equal fx, which is below the x-axis. So take for example the graph of y equal x and make it y equal modulus x. And x is less than 0, then the whole thing will just be a reflection about the y-axis. So this is just two simple questions from secondary school, I think. So you look at the two scenarios. You have 3x minus 2 is greater than or equal to 4. Or you have the negative of 3x minus 2, which is 2 minus 3x, which is greater than or equal to 4. Then you solve for x, and then you get x is greater than or equal to 2, and x is less than or equal to 2 over 3. So in that case, that's the answer. And likewise, for the other question, you have x plus 2 is less than 2x. So you have the two scenarios, less than 2x or greater than 2x. Oh, sorry. X plus 2 is less than 2x, or x plus 2 is less than negative 2x. So in this case, 2 will be less than x, and x will be less than minus 2 over 3. So that's your answer. Then another question is, on a single clearly labeled diagram, sketch y equal x minus 1 times x minus 3 and y equal x minus 4, and it asks you to solve this inequality. So to solve this inequality, you just try and draw the graph first. So this is the graph you will draw, and then you notice that there will be two intersection points. And so for this question, in order to find out when your quadratic graph is essentially greater than your modulus, you have to look at the intersection points and look before and after. So notice that the positive part of the modulus does not matter since it's out of range. Then after using the quadratic formula or using your GC, you will find that x equals 3 plus minus 13 square root over 2. So for x minus 1 times x 3 is greater than the modulus of x minus 4, look at the graph and find the range. And so in this case, it will be that x is less than 3 minus 13 square root, and x is greater than 3 plus 13 square root over 2. I think I meant to say that is 3 minus 13 square root over 2. Sorry about that. And so there are also this second kind of inequality questions, which are substitution questions. So most inequality questions will have two parts. The first part is solving the given inequality, and the second part is solving the second inequality via substitution. So you can be replacing x with 2x, or x minus 2, which is like a translation, or 1 over x, which is like creating an inverse, or even having like two of them at the same time. So you scale it to x with 2x, and then you replace the x with 1 over x squared, so you get 2 over x squared. And the thing is that regardless of the replacement, the inequality still holds if x is consistently replaced throughout the equation. So this is an example without using a calculator, solve those two equations. So the first part is that we will solve part 1, which is 1 6 over x is greater than or equal to x. So first thing first, you look at the denominator, and you know that x already cannot be equal to 0, because otherwise that fraction will not be able to be properly defined. So we try and create a common base and common denominator first. So the 1 plus 6 over x, we multiply throughout by x. So, 1 plus 6 over x, we turn it into x over x plus 6 over x. So we do that, we bring our x over to the left hand side. Because for all these kind of questions, we try and create one side that is greater than or equal to 0, or less than equal to 0, because then we can use the y-axis as a reference point. So after that, you do that, bring everything to one side. You put everything in one fraction. Then you have minus x plus 3 times x plus 2 over x is greater than or equal to 0. Then you can multiply the entire equation by x squared. And so you can do this because x squared, no matter what, is greater than or equal to 0. So when you do that, the whole equation, when you multiply by x squared, it will still be greater than or equal to 0, which is why we can do that. Then you have that final part, which is minus x plus 3 times x plus 2 times x is greater than or equal to 0. Then you just sketch a cubic graph, and then you see that it will be x is less than minus 2 and 0 is less than x, which is less than or equal to 3. Then for the second part, you notice that the two questions are actually very similar, but the only difference is that we replace x with modulus of x. So in this case, your new solution will just be taking reference from your first part, except you replace your x in the inequalities with modulus x. And so in this case, we have modulus x is less than or equal to minus 2. You can just outright reject it because it is not possible for the answer to take place. It still exists, but in this case, it still has to be rejected. So it's different from having no solution at all. Then on the other side, you have 0 is less than modulus x, which is less than or equal to 3. So in that case, you actually can remove the 0, because no matter what, you can still get a modulus which is less than or equal to 3, because a modulus will never be negative. So you then remove this modulus and then have a minus 3 is less than or equal to x, is less than or equal to 3. And the reason is that, let's say you have a minus 2 as your x. Minus 2 modulus will still be equal to 2. And minus 3 will still be equal to 3 when you put in a modulus. It's only when the magnitude, which I mean just the number, is greater than 3. So like minus 4, for example, you modulus it, it becomes 4. So in that case, that's why it cannot. So that's why the answer is just minus 3 is less than equal to x, or is less than or equal to 3. Then here's another question. Without the use of a calculator, solve the inequality x squared minus 8x plus 16 over x squared minus 4x plus 3 is less than 0. So right away, you can try and think of what is the strategy for this question. And the strategy for this question, especially if you look at part 2, they already made a completing the square technique. So the chances are that for the first part, you are going to use completing the square as well. So in that answer, you will complete the square of x squared minus 8x plus 16, which is actually just x minus 4 squared over x minus 1 times x minus 3 equals 0. So you multiply that denominator and the numerator, of course, with x minus 1 squared, x minus 3 squared. So you bring everything to just a numerator, and then you will just solve it for a quartic equation. If you're not sure how to draw the quadratic graph, you can still use your graphing calculator. They say without the use of a graphing calculator, but in this case, you can still use it secretly to just see what the graph can look like. And then you just see which portions of the graph is positive and which parts of the graph are negative. So in this case, it will be 1 is less than x, less than 3, or x is equal to 4. And so why x is equal to 4 is because if you look at the original equation, if you put x equal 4, your numerator will just be 0. And that aligns with the inequality being less than or equal to 0, which is why we say x equal 4. Then the second part, they ask you to solve the inequality x plus 1 minus ax plus a over that. So you try and break down what this x plus 1 transformation could be. And so you can do this, you can try and use trial and error to find what to replace x with. A good way is to try and see what is the difference. So you notice that they have 16 in the original equation, while 8 in bottom one. But you also have another 8x. So what happens is that when you replace x with x plus 1, you can actually get the original expression. So in this case, we can look back to our original answer and just replace 1 less than x less than 3 with 1 less than x plus 1 less than 3 and x plus 1 equal 4. And so that is how they came about to the answer of the second part. So these questions are actually quite common, and so you just need to get used to what kind of transformations are possible. You don't need to get it on the first try, but if you do it over and over again, whether it's using a transformation like letting x be x plus 1 or just scaling, placing x with 2x, somehow, some way, there will always be something available. So here's another question, which actually uses trigonometry to figure out the new transformation. So in this case, you have 6x minus 4 over x minus 3 is less than or equal to 1 minus 2x. I'm not gonna focus on the actual answer for the first part. I just want to show the transformation. So you notice that if you replace 6x minus 4, 4x minus 3, and 1 minus 2x, you replace the x with sine x, you can actually get the answer. So the right hand side is quite obvious. You just replace x with sine x. But for the first part, actually if you multiply the entire fraction by 1 over sine x, you can then get rid of the sine x in the 6 and the 1 portion. Because I have 1 over x, it's equal to cosecant x. And that's how you can get the second part. So in this case, what you do is just replace x with sine x and you're able to solve the equation. So that's basically the end of this mini rundown of the lesson. So some minor tips is that you should check and complete the square to see the positivity. Basically whether the numerator is always positive or the denominator is always negative or always positive. You also have to check your symbols and denominators, because in some case the equation will be undefined if you let x be a certain value, which will just crumble down the entire expression. Then there are questions that will ask you to basically substitute x with something else, like 2x, x minus 2, x minus 10,000 or something like that. And lastly is that although questions may ask you to solve algebraically, you can still use your GC and just try and have a greater clarity and just verify your answers, not necessarily give it a shortcut, but just to know whether you're on the right track or not. And with that, that's all I had to say. Thank you and hope to see you in the next video.